Hello, mathematicians. Let's talk about number theories and integers. So how can we know if a number is divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10, or 11? Let's talk about it. Let's look at 684. It is divisible by 2 because with the 2's test, the last digit must be 0, 2, 4, 6, or 8, or an even number. To know if a digit is divisible by 3, you take the sum of the digits and see if it's divisible by 3. In our case, 6 plus 8 plus 4 equals 18. But what if you don't feel comfortable knowing if 18 is divisible by 3? You can take 1 and 8 and see what you get. 1 plus 8 equals 9. And 9 is divisible by 3. And I went ahead and did long division to show you that we don't get a remainder. To know if a digit is divisible by 4, you take the last two digits, and they must form a number that is divisible by 4. In our case, 84 is divisible by 4. It's even, and it's divisible by 2, which is a pretty good indicator that it's divisible by 4. To know if a number 684 is divisible by 5, you look at the last digit, and it must be 0 or 5. We have a 4 in the ones place, so it's not going to be divisible by 5. 6, the number must be divisible by 2 and 3. It can't be 2 or 3. It has to be both 2 and 3. 684 is divisible by 6 because it's divisible by 2 and 3. The 7's test, you take the last digit, double it, subtract it from the original number. If the number is divisible by 7, the whole number is divisible by 7. And 684 is not divisible by 7. I worked out the problem here. 4 plus 4 equals 8. 684 minus 8 equals 676. Since 676 is not divisible by 7, 684 is not divisible by 7. And I went ahead and did long division to show you that you'll get a remainder. To know if a number is divisible by 8, you look at the last three digits. In our case, we'll look at 684 as a whole and see if the number is divisible by 8. 684 is not divisible by 8, and I went ahead and did the long division to show you that you get a remainder. The 9's test is very similar to the 3's test. You're going to sum the digits and see if the number is divisible by 9 instead of 3. And yes, 684 is divisible by 9 because it's divisible by 3 as well. And 6 plus 8 plus 4 equals 18. We know that 18 is a divisor of 9. The 10's test, you want to look at the last digit to see if there's a 0. There's not a 0 in 684, so 10 is not divisible by 684. The 11's test is you add alternating digits. So it'd be 6 minus 8 plus 4 equals 2. 2 is not a divisor of 11. And I went ahead and did long division to show you that you get a remainder. Now let's look at casting out 9s. I think casting out 9s is fun. And there's several different ways that you can work out problems casting out 9s. Let me show you the first way. You take your digits and you do like the 3's test and you sum your digits. So 4 plus 1 plus 6 equals 11. You only want a single digit, so you're going to take 11 and sum the digits. 1 plus 1 equals 2. Now I just pull my 2 over to the side. 7,490 is 7 plus 4 plus 9 plus 0 equals 20. And you want a single digit, so 2 plus 0 equals 2, and I'll pull my 2 to the side. 69,844, 6 plus 9 plus 8 plus 4 plus 4 equals 31. And what do we want here? Single digit. 3 plus 1 equals 4, and I'll pull my 4 over to the side. So 2 plus 2 plus 4 is 8. And now we want to sum the digits in our given answer, which is 1 plus 1 plus 2 plus 7 plus 9 plus 0 equals 20. And we want that single digit, so 2 plus 0 equals 2. Now you compare your remainders. we have an 8 and a 2. So casting out 9s proves that there's an error. Our given answer gives us a remainder of 2. Our casting out gives us, the casting out of 9 gives us an 8. And our correct answer is 77,750. And you just use regular addition to get your answer, the correct answer. Okay, and I wanted to show you another way on the same problem so you can see that you'll get the same answer. You can literally cast out your 9s, or if you have a combination of 9, where the 4 is after the 7, if it was a 2, 7 plus 2 equals 9, you'd cast that out. Or 8 plus 1, you'd cast out that combination. And you can see that you get the same answer. We get a remainder of 8 and a remainder of 2. And you just do the same procedure, except for you leave out your 9s. That's so amazing to me. 7 plus 4 plus 0 is 11. 1 plus 1 equals 2. 6 plus 8 plus 4 plus 4 equals 22. 2 plus 2 equals 4. And you do the same in your given answer. I love it. Okay, let's look at subtraction. Subtracting, you can do the same procedure where you add the sum of the digits. 7 plus 6 plus 3 plus 6 plus 2 equals 24. Remember, you want the single digit, so 2 plus 4 equals 6. And 3,674 is 3 plus 6 plus 7 plus 4 equals 20, or 2 plus 0 equals 2. Here, you're going to subtract 6 minus 2, and you get 4. Your given answer is 7 plus 4 plus 6 plus 7 plus 8 equals 32, and you want the single digit, so 3 plus 2 equals 5. Compare your remainders. We have 5 and 4. So casting out 9 proves we have an error in our arithmetic. And our given answer gives us a remainder of 5, and casting out 9s gives us a remainder of 4. And our correct answer is 72,688. And you just use regular subtraction to figure out your correct answer. Another way to cast out 9s is where you divide the number by 9. Let's look at this multiplication problem. 337 divided by 9 gives you a remainder of 4. 620 divided by 9 gives you a remainder of 8. Multiply your remainders. 4 times 8 equals 32. And what do we want here? A single digit. So 32 divided by 9 gives you a remainder of 5. Now do your given answer. 209,940 divided by 9 gives you a remainder of 6. Compare your remainders. Casting out 9 proves that there's an error. Our given answer gives us a remainder of 6. Our casting out 9 gives us a remainder of 5. And the correct answer is 208,940. I chose to do the box method for multiplication this time. And then question number 3. Show which rods will measure the 9 rod. You want to find the divisors of 9. So 1, 3, and 9. B says show which rods will measure the 6 rods. 1, 2, 3, and 6 are the divisors of 6. Use the parts A and B to show the greatest common divisor of 9 and 6. I wrote them out. Divisor of 9 is 1, 3, and 9. Divisor of 6 is 1, 2, 3, and 6. And now you need an intersection. It has to be a number that is in both places. That's the largest number that's in both places. And ours is 3. Place the 10 rod and the 8 rod end to end to form an 18 train. Recall that a train is formed when one or more rods are placed end to end. So you want to find the divisors of 18. 1, 2, 3, 6, 9, and 18. And E says show all the lengths of all rods or trains which can measure the 18 train. And remember, a train is whenever you place a rod end to end. And here's the combinations that I came up with that would equal 18. 1, 3, 4, and 10. 4, 5, and 9. 1, 2, 3, 4, and 8 equal 18. 8 and 10 equal 18. These are rods that you can place end to end to form an 18 train. And if I was teaching my students, I would, since we already know the divisors of 9 and 8, I would form groups. I have a 9 group and a 6 group, and we would place the divisors in each group. And I would ask them which numbers are in both group, and they would tell me 1 and 3. Then I would ask which one is the greatest common divisor of both. And I would help them realize that even though 1 is in both groups, it's not the rod with the most value. 3 is in both groups and is the rod with the most value. Least common multiples of 48, 25, and 65. First, you build your top row of 48, 25, and 65, and 2 goes into 48, and you get 24. 2 does not go into 25 or 65, so you bring them down. 2 goes into 24, you get 12. 2 goes into 12, you get 6. And then 2 goes into 6, you get 3. Now we have a prime number, so we're just going to continue to bring it down. 5 goes into 25 and 65, and you will get 5 and 13. You continue to do this until you get a prime. So the least common multiples of 48, 25, and 65 is 2 to the 4th power. But how do you get the 4th power? Well, you count your 2's, 1, 2, 3, and 4. So we have 2 to the 4th power times 3 times 5 to the 2nd power times 13. You don't have to put the 1s on there. That is not necessary. And then let's look at the gear problem. So we have a large gear, 84, and a small gear of 48 teeth. How can we figure out when point A and point B will meet again? How many rotations will it take? Factor out 48, 2 times 24, 2 times 12, 2 times 6, 2 times 3, until you come to your prime numbers, because they can't be factored out anymore. The least common multiple of 48 is 2 to the 4th power times 3. Factor out 84, 2 times 42, 2 times 21, 3 times 7. The least common multiple of 84 is 2 to the 2nd power times 3 times 7. Then you want to take your numbers with the highest exponent in both groups. So it would be 2 to the 4th power times 3 times 7, and you get 336. Take 336 and divide it by 48, which is your smallest gear, and you'll come to 7 revolutions before teeth A and B meet again in the same position. Magic squares. So you're going to take your given digits, which is -7, -6, -5, -4, -3, -2, -1, 0, and 1, and you're going to add them together. You get -27. 3 will go into -27, and you divide it out, and you get -9. So our magic square has to equal 9 for each row, each column, and each diagonal. And I hope you've learned a lot today, and I hope you enjoyed learning with me. And remember to remain calm and love math. Bye, everybody.